Section 5.5, Graphs of Sine and Cosine Functions. We're going to be looking at the graph of y equals the sine of x. Here are some of the angles that we have found the sine value in the past, and here's the sine values that we obtained. To make our graph, we're going to be interested in what we call the 5 key points. So this graph we're going to look at when x is 0, y is 0. So when the angle is 0 degrees or 0 radians, we're at a height of 0. The next key point is going to be at 90 degrees or pi over 2. We'll be up at a height of 1. At 180 degrees or pi, we're at a height of 0. At 270 or 3 pi over 2, we're at a height of negative 1. And finally, we finish the cycle at 2 pi or 360, back at a height of 0. Notice that the graph increases as we go from 0 degrees to 90 degrees. It decreases as we go from 90 degrees to 180 degrees. It goes from 0 down to negative 1 as we go from 180 degrees to 270 degrees. And then finally it goes from negative 1 back up to 0 as it moves from 270 degrees to 360 degrees. As we explore the graph of y equals sine x, we're going to be interested in these 5 key points. Notice that instead of having our angle be angle theta that's cycling around the vertex at the origin, we're instead having our angle be x, and therefore it can go infinitely in both directions. So we say that the domain is negative infinity to infinity. And then the range are the y values that it can take on. So notice that starts as low as negative 1 and goes up as high as 1, with those endpoints being included, so we use the square brackets. The period is 2 pi, shown here in yellow, and that period continues to cycle over and over again, so we could take it to the right, and we can take it to the left. This function is an odd function, which means the sine of a negative angle equals the negative of the sine of that same angle. When we graph the cosine, we'll use a similar approach. We'll take a look at the 5 key points. At 0 degrees, we're at a height of 1. At 90 degrees, a height of 0. At 180, we're down at negative 1. At 270, we're back to a height of 0. And then finally, we finish the cycle at 360 at a height of 1. To graph the cosine, we will be interested in these 5 key points. The cosine, like the sine, has a domain that goes from negative infinity to positive infinity. Its range is also from negative 1 to a height of 1, and the period is also 2 pi. The cosine is what we call an even function. This means the cosine of a negative angle is the same as the cosine of the corresponding positive angle. We're going to need to graph variations of the sine graph and the cosine graph. These equations can look very intimidating, but we'll take it one step at a time. To begin with, the coefficient a will vertically stretch or shrink our graphs. The coefficient b will horizontally stretch or shrink our graphs. If we change c, that will shift the graph left or right, and if we change d, that will shift our graph up or down. We'll begin by looking at the impact of a and b on our graph. A affects the amplitude. The formula for the amplitude is the absolute value of A. And B affects the period. The formula for the period is 2 pi over B. Let's look at the example y equals 3 sine of 2x. First we'll find the amplitude. Since the value of A is 3, our equation for finding the amplitude is the absolute value of A, so our amplitude is 3. This means that the maximum value of y is 3 and the minimum value is negative 3. Next we find the period. The value of b in our equation is 2, and the formula for period is 2 pi over b. So we substitute in the 2, and we simplify that to pi. This means that the width of one full cycle is pi. Our strategy for graphing variations of sine is to first identify the amplitude and period. Then we find the values of x for the 5 key points. 3 of them are the x-intercepts, the maximum point, and the minimum point. We start with the value of x where the cycle begins and add quarter periods. So this starts at x sub 1. 1/4 of a period takes us to x sub 2, then x sub 3, x sub 4, and x sub 5. These are the x values of our points, so we'll use those to find the y values of our points. Once we have our 5 points, we'll graph those, connect them with a smooth curve, and then occasionally we're asked to extend our graph to the left or to the right. So we'll do that as needed. For example, graph y equals 2 sine of 1/2 x on the interval from 0 to 8 pi. First, we identify the amplitude and the period. Our equation has an a value of 2 and a b value of 1/2, so our amplitude is 2. Our period, 2 pi over b, we substitute in 1/2. 2 pi divided by 1/2 is the same as 2 pi times the reciprocal of 1/2. 2 pi times 2 is 4 pi, so that's our period, which means the maximum value of y is 2, the minimum value of y is -2, and the period of 4 pi tells us that one complete cycle goes from 0 to 4 pi. For step 2, we're going to find the values of x for our 5 key points. We begin by taking our period and dividing it by 4. The quarter period is pi. The cycle begins at 0, and that is our first point. Our second x value, we add our quarter period to that, so that gives us 0 plus pi is pi. Our third x value, we add pi again, which takes us to 2 pi. For our fourth value, we add pi again, giving us 3 pi. And finally, our fifth value is going to be 4 pi. So we take our 5x values and we substitute them into our function. When we plug 0 in, it simplifies to 0, so we get the point 0, 0. Plugging in pi, we get 2, so that's the point pi 2. We then continue to substitute in the remaining values, and we get our 3 remaining points. Step 4 is to graph those 5 points. So we take our first point, and it's at a height of 0, the second at a height of 2, then back to 0, down to -2, and finally back to 0. Our amplitude is 2, and our period is 4 pi. In step 5, we recall that they wanted us to graph this from 0 to 8 pi. So we need to extend this another cycle to the right. So we've explored how to find the amplitude and period using A and B. Now we're going to see how to find the phase shift with the formula C over B. The phase shift will move the starting point of our graph to the left or to the right. In this example, we're asked to find the amplitude, period, and phase shift of the function, and then graph one period. We'll begin by identifying A, B, and C. Notice that C is positive. This is because there's a negative in the formula. We take A and find the amplitude of 3. We find the period by substituting 2 in for B, and that reduces to pi. And then to find the phase shift, we use the formula C over B. That's pi over 3 all over 2, which reduces to pi over 6. For step 2, we find the x values of our 5 key points. Since our phase shift is pi over 6, that will be our starting x value. From that starting x value, we need to add a quarter period. Since the period was pi, the quarter period is pi over 4. So x sub 2 is the pi over 6 plus the quarter period. That simplifies to 5 pi over 12. To get our next x value, we take the 5 pi over 12 and add another quarter period, and that reduces to 2 pi over 3. Making room for x sub 4, we take x sub 3 and add another quarter period, and that gives us 11 pi over 12. Then we take x sub 4 and add another quarter period, and that gives us 7 pi over 6. These are the 5 key x values. We'll use those to find our y values. The first 3 x values are substituted in here. You're encouraged to pause the video to review these simplifications, but we get those 3 points. And here's the work for using x sub 4 and x sub 5 to find the last 2 key points. Step 4 is to plot the 5 points and connect a smooth curve between them. So there's our 5 points, and there's the curve. Notice the phase shift of pi over 6, the period is pi, and the amplitude is 3. The graphs of sine and cosine are called sinusoidal graphs, or sine waves. The graph of the cosine is actually the graph of the sine with a phase shift of pi over 2, which means the cosine of an angle equals the sine of that angle plus pi over 2. Graphing variations of the cosine graph are very similar to those of sine. The amplitude is still the absolute value of a, and the period is 2 pi over b. Let's look at this example. Determine the amplitude and period of y equals -4 cosine of pi x, and then graph the function from -2 to 2. Step 1 is to identify the amplitude and period. Since a equals -4 and the amplitude is the absolute value of a, we get 4 for our amplitude. The period is 2 pi over b, with b being pi, that reduces to 2. In step 2, we find the values of x for our 5 key points. There's no phase shift, so x sub 1 is 0. And then from x sub 1, we have to add a quarter period to get to x sub 2. Since the period was 2, a quarter period is 2 over 4, which is 1/2. So we'll add a half, and we get a half. And then for x sub 3, 4, and 5, we continue to add a half, giving us key values of 0, a half, 1, 3/2, and 2. We take those values and find the y values, which give us these 3 points and these 2 points. So now we can connect our 5 points. Draw our graph through the plotted points. Note our amplitude was 4 and our period was 2. Finally, they asked us to extend the graph to the left or right as desired, and we were told to go from -2 to 2. So we'll take our graph and extend it all the way to -2. Cosine also has the same formula for phase shift, c over b, so let's look at an example. We're asked to determine the amplitude, period, and phase shift of this function, and then graph one period. We start by identifying a, b, and c. The amplitude is the absolute value of a, which is 3/2. The period is 2 pi over b. Since b is 2, that gives us a period of pi. And the phase shift is c over b. Notice that c is -pi. In our equation, it says plus pi, and in the generic equation, it says minus c. So in our equation, we must be looking at a minus -pi. And so therefore, -pi over 2 is our phase shift. So now we need to find the x values for our 5 key points. X sub 1 is the phase shift, which we found to be -pi over 2. From there, we have to add quarter periods. Since the period was pi, then 1/4 of that is pi over 4. So to get to x sub 2, we'll add pi over 4, and that simplifies to -pi over 4. We take that value and add pi over 4 to that, and that gives us 0, and we continue on adding pi over 4 to get these 5 key values. We take those 5 key x values and substitute them in to find the corresponding y values. You're encouraged to pause the video and review the work for the first 3 points here. And here's the work for points 4 and 5. Step 4 is to connect the 5 key points with a smooth curve. Here's our points. We make our graph. Note that our amplitude is 3 over 2 and the period is pi. For sinusoidal graphs of this form, the constant d will cause a vertical shift in the graph. Up if d is positive, down if d is negative. And such shifts will cause the sinusoidal graph to oscillate around the horizontal line y equals d rather than around the x-axis. The maximum value of y will be d plus the amplitude, and the minimum value of y will be d minus the amplitude. In this example, we're asked to graph one period of the function y equals 2 cos x plus 1. We start by identifying a, b, c, and d. We use a to tell us the amplitude is 2. We use b to give us the period of 2 pi. The phase shift is c over b, which is 0 over 1. That reduces to 0, so there is no phase shift. And finally, our vertical shift is obtained by looking at d, which is plus 1, so our graph will be shifted 1 unit upward. Next, we need to find the x values for our 5 key points. X sub 1 is 0 because there was no phase shift. We found the period to be 2 pi, so the quarter period is pi over 2. Therefore, we'll add pi over 2 in successive values to get our 5 key x values. We take those x values to our chart, and we substitute them in to find the y values, and therefore we have our 5 points. In step 4, we graph those 5 points, and we draw a smooth curve through it, and that is one complete cycle of our function.